Can everyone hear me standing here? That better? Okay, good. The first thing I want to say is that GK is his name, goes by the name GK. His real name is Gopala Gaddipati, so we call him GK for short. But the first thing I want to say is we did not intentionally dress this way together. It's a miracle because at T-Mobile, we have a lot of gear that we get. And so it's almost a miracle that we're actually wearing the same thing. Today we want to talk to you about our journey in cloud. It's been a 7-year journey, and we want to condense that down to 30 minutes. So some of the things you'll hear a little bit more higher level, but we can dive down into detail if you want. First things first, T-Mobile. How many people don't know about T-Mobile? Hopefully no hands go up, right? We do find surprise sometimes when we talk locally that people don't realize that T-Mobile is headquartered here in Bellevue. We have 81 million customers. We have a couple different flagship brands with T-Mobile. Our primary brand, Metro, is a T-Mobile brand, and T-Vision now, our TV product. We have 50,000 employees with a multiple of contractors as well, and we're structured with engineering groups and what our group is, a product and technology group, to deliver many different types of services to our cellular providers, including things like free Netflix and real humans for customer service. T-Mobile, even if you're not a T-Mobile subscriber, you've been affected by T-Mobile because over the last 4 to 5 years, we've really driven the wireless market. You have unlimited data, text today, and calls due to changes that T-Mobile made to the industry, regardless of your provider. And so we've really been pushing the industry forward. For example, one difference is that taxes and fees are included with T-Mobile, whereas they're not with your other provider. You get Netflix for free. You talk to real people when you call our customer service. And so to bring all these services to our customers, it takes a lot. We are from the smaller part of our organization is called customer experience. We focus on exposing various different services to our end user customers, like our T-Mobile, myT-Mobile.com site, where you can change your plans and do other service-oriented things. It takes about 14,000 APIs to deliver all the services across hundreds of different applications at T-Mobile to be able to deliver that. And over the past several years, we've adopted both on-prem and in the cloud, massive adoption of cloud-native technologies with containers and serverless and other types of technologies. In the public cloud space, GK and I are on the public cloud team. We've now been doing this for 7 years. We have 75 plus applications running on the cloud in production, many more in the queue. We do this across both AWS and Azure, and we integrate that into our data center network. On the container space, we have over 50 container-based applications. We've been doing this now for 3 years, building out a massive container-based application platform. We'll talk about that at the end here. The types of things we do using the public cloud, you just heard a little bit about lift and shift versus building native. We've been primarily building cloud-native applications. We haven't done any straight lift and shift of applications, primarily because we're not under any economic pressure to do so. We don't have any data centers that close where we need to move. So we've been purposeful about the way we approach building applications. So our T-Mobile.com website, myT-Mobile.web website, those are two different things, two different groups. Metro, Netflix integration, we have retail agent applications, many other. We're really big in the social application messaging space where you can actually talk to us via text as opposed to calling on a phone. One big area that we do on the cloud is we have a fairly significant data analytics presence on the cloud, and that's one area where we're growing very, very fast. So that gives you some kind of the idea of the scale we have on the cloud. GK and I are now going to walk you through 6 different areas where we've had lessons we've learned in building out this journey over the past 6 years. And GK is going to start with network security, I'm going to come back to cost and self-service. We'll switch again for talking about multi-cloud and wrap up with some things we've done by building platforms for the teams. So go ahead, GK.
Thank you, Thom. As Thom stated, we started our public cloud journey 7 years back. So we started with web application deployments on cloud, and these applications have a dependency on on-prem systems, and on-prem systems has to communicate back to systems on cloud. So we evaluated few options, how the connectivity between our on-prem systems to public cloud. We started with VPN, and then quickly we moved on to private circuits with cloud providers. VPN, we ran into the challenges of scale. Our scale, we were not able to transfer the data with the speeds that we were expecting, so huge performance issues. During this process, what we learned was a backhoe can take out your network.
This happened.
Yeah, this actually happened. The winter weather in Utah could disrupt your network by delaying your recovery. Route corruptions can disrupt your services. So to overcome these challenges, we designed network in such a way that these failures won't interrupt our systems and we can continue business as usual. As you see from the diagram, all red, blue, and black dots are our locations. They are all interconnected with our high-speed fiber network. We established a private 10 gig circuits with our cloud providers at different regions. If you see like west, east, and central locations. Both on AWS and Azure, we extended our network, deployed with our own private IP space, and established a connectivity to traverse privately between these providers. Once you are on AWS, you can reach to on-premise, and also Azure, same thing from Azure as well. So we don't have to traverse over internet, or because they're all interconnected to our backbone. Once we come onto our network, we can traverse anywhere. We also built a port redundancy, so we don't have a single point of failures at any layer of network systems. Monitoring. So these circuits, when fiber cuts happen, like backhoe can tear down your network, so you need to have an alarms. Typically, circuit level monitoring, we have both on-prem side and cloud side. We established some monitoring and alarms. When these circuits go out, they will send a notification. But there is another type of issue. Sometimes there will be asymmetric routes happens due to various changes done by either on cloud side or on-prem side. Service won't go down, but there will be a huge performance impact based on how the routing is happened. We have some sensitive applications that are running, which can tolerate the latencies. So we built some monitoring to observe these kind of issues and send notifications. So this way, we ran into challenges, fiber cuts, but we never interrupted our applications or any of our services. Moving on to security. Back in 2012, that is where we started our public cloud deployment first time. When we ideate about, hey, moving or migrating, deploying our services onto public cloud platforms, the first concern was security. As you may be aware, data centers, the way you access services or allow people to how they communicate or connect to the systems are tightly controlled, and on privately you access these resources. Whereas on the cloud services, they are open to internet. You can access these services over internet. this is a huge security paradigm change for our security teams. So we engaged our digital security organization teams on day one, built a security framework that covers each layer of the platform and application at cloud. The way we operate is slightly different. We enabled our DevOps, we operate through DevOps model on cloud. So we enabled our DevOps teams to go launch, deploy applications, and manage and operate these particular systems. That brought us opens up a new challenges. Not all dev teams are on par on the same line with when it comes to the security. People started opening their services to public access, whether they are, sometimes they may need only internal facing services, but still like opening up into the public services, public access. Second one, using the marketplace images, not hardening and launching these systems. Once you have internet access, and if the default configurations left on the systems, people will easily attack and access these systems. So we built a framework called PackBot, which proactively monitors all security violations. T-Mobile defined a certain policies. These are the security standards. So we implemented and continuously monitor these security policies through PackBot and send an alert whenever any of the service violate our policies. We also have auto fixes for specific policies. Example, if there is a S3 bucket opened to the public access, PackBot will detect automatically and it auto fixes public access. There are some genuine cases or like genuine applications require a public access. For example, website hosting on S3. So that requires a public access. Those are all like, there will be, if there is a real use case, there are some exceptions and into these policies we baked in and allowing users to access. Another security from the, what we learned or initial days applied was using identities. When it comes to the identities, we started with local identities at cloud providers. Quickly, it became an operational overhead and challenge to manage identity lifecycle of the users. So we extended our identity systems and integrated with our T-Mobile IDs. So devs or operations teams doesn't have to use their local identities and use only T-Mobile IDs across on-prem cloud, any cloud platform. Next is account strategy. When it comes to the account, we started with the single account, but quickly grow into the multiple accounts. We created multiple accounts for shared services and also for the applications. We segregated accounts, application accounts and shared service accounts. The way we created application accounts was based on the data classifications. But our growth is enormous. So all these cloud services have service limits based on the accounts. So we had to change our strategies and quickly moved on to account structure that is based on the business functionality and domain models, etc. So when it comes to the account strategy, it depends based on what your needs. You have to carefully design your account strategy. That said, we'll move on to the cost, and Thom will talk about how we are managing the cost.
Yep. So now we have, if you think about it, two legs of the stool, the important infrastructure set. Now, how do we enable agility through the organization? Because that's the reason really why you adopt, one of the big reasons why you adopt the cloud is to gain the agility you need. So there's a third part of that, and that is cost. Anyone who's ever used the cloud before, any cloud service has gotten a surprise bill. So how do you tame that? So for us, we have, as I said, 75 applications in production, but we have many more in the queue. So one of the things we do is we set up a budget for every single line item. And it's important to do that so that you can make sure that every single piece is actually at least budgeted and then operating within that budget. Secondary, you want to be able to routinely show back and charge back that spend to specific business units, and so that's something we do as well. So we'll have this constant demand. Agility the agility you get in the cloud will drive constant demand in your organization and large-scale use. So you really need to have this organization or a set of people in your organization that has this combination of financial awareness and technology awareness so that when you see something, you can immediately get to the bottom. And there's a couple of examples here that we've seen in the past where a developer might be working on a project, for example, and add dedicated IOPS or provisioned IOPS to an instance. And what that does is gives them greater performance on that instance. And then when you talk to the developer further and you say, well, how big is this project going to be? Well, this is going to be 50 servers. And you work that out in your head and say, okay, that's going to be a ton of money. So you have to back off from, okay, which machines actually need that throughput and which don't. And so we were able to iterate with teams on that to make sure that we weren't leaking money specifically because things were over-provisioned or were using features where we didn't need them. Elastic file store is another one that has some really great uses for us, for example, in our pipeline. But it's very easy to kind of use this for other purposes where it's not cost efficient and see that grow. And we've seen that as well, and we've reined that in. So you really need to have this continuous loop, both from a budgeting point of view and from a utilization point of view and a technology point of view to continue to drive these costs down. The one great thing about being in the cloud is that it creates a lot of data. And so the primary thing you need to do is use that data. And what we've done is we've built a data lake that pulls in all of our cost data from both clouds that we consume today. And we also bring in a lot of our monitoring data. And so we actually merge those data and provide viewpoints on cost and utilization down to the memory level, down to the container level on all the applications that we have. And so we can provide an additional level of feedback to teams. A big win for us has actually been in normalizing the consumption of the cloud by delivering platforms, and I'll talk about that in just a second. But the more you can normalize your approach, the better off you'll be in terms of having different teams do similar things within your organization. You're going to find in our organization is very large, so we have wide variations in teams' ability to look at this information and do the very same thing. It's very hard to get 100 teams talking to each other and referencing architectures. So building out architectures and platforms is really important to do that. Pricing is a really important factor, obviously, when you're looking at something, but utilization is actually a more important factor. Something can be cheap and you use a lot of it, or something can be expensive. You really need to watch from a utilization perspective how you're consuming things. And one of the big things that we saw, especially in the containerized environments, was memory really drove the cost. And it's a little bit counterintuitive because if you look at the price list of an instance, you'll see the CPU cost is more. But what we've seen is that applications are requesting more and more memory when they don't really need it. And that request for more memory turned into requests for machines that have more CPUs. And we're paying for CPUs, but the memory is actually driving that cost. So that's an important thing that we've learned. Especially once you normalize your architecture, you can actually measure it pretty well. So another component of the cost and driving agility is in a large organization, how are we going to deliver the cloud to the whole organization? And we realized early on the way we started might not be how we end up. So our starting point in 2012 was everything was done by the cloud team, whether it was the network, identity management, the we're working with all the cloud providers, doing the security, building the applications and the DevOps as well for the infrastructure. Infrastructure as code. The platform, the CI/CD pipeline with Jenkins was built by our team. And global traffic management was done by our team. But what we realized, if we were going to continue to take on all these roles, we'd need a really massive team. So what we started to do is we started to move these functions back into various different application teams, where there's an application team driving something, or a service provider team, which there are many at T-Mobile as well. So each application team coming to the cloud today, while we might help them get up to a certain level, they're responsible for building out their own infrastructure and their own DevOps infrastructure, their own pipelines now today. Where we do have centralized pipelines, we have moved those into service groups within T-Mobile. And where we have teams that are working with networking, firewall, and global traffic management, we have moved those functions into that group. So a big lesson for us to reduce the friction, reduce the size of our central team, was to distribute the responsibilities throughout the organization so that you can really gain this, ensuring the common practices and building the automated tooling to achieve that. Self-service works well when you do have the automated tools like PackBot, like access management, where you can use your AD, Active Directory management, so that people can access those tools themselves. So you're eliminating some of the friction it takes to run some of these applications. So self-service was a big component for us to really extend from one team to many. And then the next thing that was on the plate for us as a company was to drive this to multiple clouds. And I'll have GK talk about our strategy there.
Yeah, we adopted multi-cloud strategy and onboarded AWS and Azure. This enabled us to leverage best-of-the-breed products and services. Also, we have at T-Mobile, we use different technology stacks, and our skill set varied from Microsoft-based technologies, open source, Java, etc. So we were able to, with multi-cloud strategy, it was very easy for us to migrate or deploy applications and adopt cloud easily, because the section of the people who are familiar with Microsoft technologies or the platform services that more suitable on Azure, they went on to Azure and deployed their services. Same thing with AWS. Initially, we are not planning, we are not running similar applications on cloud and on-prem. What that means is, if I have mytmobile.com, we are not deploying the same application on-prem, also on the cloud, and burst the traffic or doing. The main reason was, initially we tried, but the ecosystem parity is vastly different from on-prem to cloud. We were able to make some applications work, but it is a heavy lift, because the platforms, so tools, services, and monitoring systems, everything, also the deployment, DevOps cultures are different from on-prem to cloud. So we abandoned that idea and choose where the application fits best, whether it is on cloud or on-prem, and if it is on the cloud, whether Azure or AWS. That is the strategy we adopted. Also, we do a lot of acquisitions or buy products from vendors. With multi-cloud strategy, that give us the flexibility to migrate these applications during the acquisitions or buying the product seamlessly. That said, we'll move on to platforms, and Thom will talk about what is our platform strategy, how we are doing that.
So, as I mentioned, one of the things that we've done is, and I characterize it as normalized consumption. And we've hit a major milestone in this past quarter for us. And when you're thinking about digital transformation, this is an interesting way to think about it. We've recently passed 10,000 containers that we host on on the AWS side on the cloud. That actually exceeds the number of instances or VMs that we have by a pretty decent margin now. And what we've seen over the past 6 months is that growth rate of containers continues to grow rapidly at 42%, for example, over the past 6 months, whereas our growth rate on VMs is actually at 0%. So that's a good indicator that we've actually kind of put that digital transformation in place and are now operating in a way where we have a container-based primary infrastructure running at T-Mobile. Now, if you consider the fact that a good portion of those VMs we're running are actually container hosts, we're actually growing negatively in VMs. And so this is actually a fairly big achievement overall for the company, so that we can say that we actually have kind of moved what we call moving right or shifting right. So we've built these platforms. But one of the most important things you can do when you build these platforms and build distributed applications is bake in observability right from the go. So for every application, so we have an internal platform called Conductor, which hosts the container applications. And we make sure that you cannot launch on this platform without having telemetry. It's just baked in. And so the scale of this, the platform now has reached, we've done 45 billion API requests so far this year in 2019. We do about 500 million API requests a day. That's actually growing somewhere around 3K to 14K requests per second across all these applications. So it's reaching a pretty good scale, supporting many of the applications that I discussed earlier. Our go-forward strategy is primarily on Kubernetes with our container-based strategy. On serverless, we have an internal product called Jazz, where we have teams consume, if they're building a website or an API or something like that, they consume our Jazz platform. But I would like to relay one big advantage that we've had in building and normalizing containers. And that is our ability to manage our reserved instances on AWS. On AWS, obviously you've probably had the experience of managing reserved instances and seen some go through your system unused or underutilized. And so what we've done is, since we're managing this large platform, we can actually manage the instances. For all the other applications across the company, it's a little harder to know when a team is going to switch an instance type, and we don't want to hard code what instance types people can use. So we've actually inched up our coverage of reserved instance from somewhere around 50% of our hours up close to 75, and now getting above 75% of our hours on reserved instance, primarily because we have this pretty big footprint now of the containers. And our utilization over the past year has been greater than 98% of our reserved instance across that platform. As we push up, our goal is to push up to around 80%. We recognize that's probably the utilization might dip a little bit, but we're very comfortable with the math to say that as long as we get more than 90 and 95% utilization of reserved instances, we're actually getting a really big bang for our buck here. So that's been one of the side benefits of getting to containers, aside from all the normal benefits we typically talk about. So I think I think we're at the end of our time, and we want to leave time for questions, but hit us up outside so we can go.
Why don't Luke from Blooming could come up, and we'll get your presentation going, and then you two can answer a couple of questions while we're doing that.
Sure.
In the transition. Any questions for GK or Thom? I was personally fascinated by the fact that you're kind of doing the hometown multi-cloud. Just don't piss either of them off, right? Just go with AWS and Azure and just forget Google Cloud.
They're all
that's the way you do it in Seattle.
Google's here too, right? So
Well, they're not. Well,
their cloud is, right?
wow, this is devolving into a scary discussion. Any actual questions? There we go. Yeah.
GK and Thom, thank you for the information. So it's good to see that you are using both clouds, AWS and Azure. What are your experiences using them, and which one do you think that better, or what features you like in AWS or Azure? I know it's a complicated question, but love to learn some lessons.
Well, a good thing is they took our mic away to answer that question. So. Okay, so he wants to know which cloud is better. Obviously, the answer is right. No, not Google yet. As GK said, we use the clouds for different things, and just the pattern of our consumption may be different than others, but primarily, given the history of AWS, we use it for primary infrastructure products or projects where people are rolling out instances, and that's been our history. Obviously, the container side, we do that now. One of the areas where we've adopted Azure pretty big is in data analytics, and so there's a nice tool set on Azure. Including Databricks that's baked in. So that's actually been one area we've seen some success on Azure. So we're still, given that we've been with AWS for 7 years, by far, bigger presence in AWS, but we see a real advantage to using both for specific cases.
Yeah, features-wise or the technology-wise, they are very competitive. Let me put it in that way.
Yeah, it seemed from what I've gleaned is that you picked one or the other based on the relative strengths and the nature of the application that you were doing. And the other fascinating thing that I found, so you're not doing lift and shift. It's what a luxury that is.
I think a luxury, yeah. And I think the primary reason a lot of companies end up doing that is because they end up in a data center that's like 15 years old or 20 years old, or a colo where they have a lease that they have to kind of sign up again for. And we're just not in that position. We have modern data centers that we've recently built. And so there isn't a pressure to say, hey, we have to get out of here and onto the cloud. And we've been able to you're right, I guess that's a luxury to say we've been able to take our steps and do it.
The other one is if the applications are going on to cloud, we are not looking cloud platforms as our infrastructure extension or like there is like a capacity requirements. We made like applications has to go, whatever the applications we want to deploy, they have to be cloud native. There is no point in moving monolithic applications, deploy there and operate it like data centers. Scale up, scale down, and effectively cost also, the entire ecosystem, correct? We need to increase the agility with lower costs. So you cannot like really lift and shift, manage it, operate it like what you do on data centers. That is not very effective. That is the reason we went with cloud native.